Welcome everyone. AI is not God-given. AI is also not built by just one company, and it's also not just one tool, at least not in the close future. In the close future, AI is built by a lot of humans using a lot of different tools that are amazing, but still they are just tools. And the AI is built by humans to bring that in production. And one of these amazing tools is our large language models like GPT. We got this 1.5 years ago, but there are a lot of other nice tools. And in the next 20 minutes, you will learn about a second vital technology whenever building an AI application, and you will learn how to combine it with large language models. And the second technology are embeddings. Welcome to Empower AI, building smarter solutions with embeddings. I'm Maximilian Werk from Gina AI. And in Gina AI, our mission is to lead the advancements of multimodal AI through innovative embeddings and prompt technologies. A lot of fancy buzzwords here. Today, I will ignore the prompt part and only talk about embeddings and bring you this technology closer. So, who of you has used GPT? And who of you has used other large language models than GPT? Okay, I'm surprised so many. Nice. And who have a real work application at work where you believe GPT is really helpful for you? Wow, nice. And who is frustrated from the results of GPT? Nice. And who ever used embedding models? Oh, nice. You come to me, talk later. Cool. So my main question that I want to ask initially is how can I use GPT on my private data, on my company data, in order to solve a certain problem that I have? And I want to remove GPT here and say a large language model, because a lot of people, especially when it's about private data, you don't want to send it anywhere else, you want to have it on your own system, so let's talk about large language models here. And the specific problem I want to talk about is, okay, you have one question or a task, and you want to generate for this question or task a correct answer, and ideally some further relevant information. And these questions or tasks, I have brought multiple for you, could be, so for example, what is my allowance for conference trip spending? Some of you may have had this problem in the past weeks. Or when was the family of elephants first described? Not so many had this problem, I guess. Or in which episode of the Perfect Podcast did John Doe talk about his new bike, and which 3 main advantages he mentioned? Which is a little bit more than just a question. It's also summarizing something, so most probably he mentioned 5, and so the model needs to do a little bit more. Or summarize the discussion about purchasing or renting GPUs we had in January 2024. If you have an AI company, you may know this discussion and may want such a summary in the future. So, and especially the last one needs some internal company knowledge, needs access to company data, and most probably you don't want to first go to Slack and get this discussions and then send it to GPT, but you want this automated. So you want to automatically find the correct context of your problem. So in order to solve this problem, we will need a little bit more steps, and I will explain all the steps that are in between here that we need in order to go from a question and a task to the correct answer and a lot of further relevant information. And first, before I go to embeddings, I want to go to large language models and explain what their role is in question answering, and then afterwards, what is the role of embeddings. So a typical example that what people do when they use GPT or other large language models, they ask questions. For example, when was the family of elephants first described? And then GPT answers, the family of elephants, known as Elephantidae, was first described scientifically in 1825 by the French naturalist Georges Cuvier. Pretty nice. It corrected elephants to the actual family name, so it seems to know a lot. That's really good. And one feature that might not too obvious to you is I put text in and I got text out. So the input and output of the model is text. But actually, this is wrong, and it's hallucinated. So the model made up some facts. That is not true. But turns out when I ask the same question and I give the full Wikipedia article about elephants to this model, then it can very precisely answer it and give me more context, and it works pretty nicely. So having more context is very good and actually makes the answer correct. So that answer is correct. So to summarize these 2 findings somehow is when I just have a question, I possibly get a correct answer or incorrect, you never know. But when I have a question and I know already I have the document that contains the relevant information, then the large language models are usually very precise and can do the question answering correctly. So that's what I just said. the large language models are really good in processing data or text and in text synthesis. So they can do good stuff with text when they have already the correct information. So if I only would have the question and the documents with the relevant information, then I could use any large language model to provide me exactly the interaction that I want to have. But now, okay, guess what? We need to go there and we somehow need to figure the correct document for a question, which are relevant documents for a certain question. And obviously, when I want to talk about embeddings, then now they play a crucial role here, and I will explain in a moment how they go into this direction. But before I explain how embeddings solve this problem, I want to give you an idea what are embeddings. So some of you have used them. For you, it might be boring the next 3 minutes, but for the rest, I hope you get an understanding what embeddings are. Embeddings are nothing else than a vector. So just a number or several numbers in a row. And how you can imagine embeddings is, think about you have the euro coins and you want to somehow represent them. They have diameter, they have thickness, and they have weight. And I can print them in the 3D space by these 3 parameters. And when I do this, I get a nice distribution of these coins in the space. And this looks like, a line from low to high, looks kind of decent. So, and a good embedding, what does a good embedding have? So items that are similar to each other are close to each other. So the big coins are close to each other and the small coins are close to each other. The second good property of an embedding, to put something in the space, is that not so similar items are far away from each other. So in this case, the small coins are in the left corner and the big coins are in the right corner. And then there's a third very important property of embeddings. It's they should have continuity and gradual transition. Okay, fancy word. What does it mean? It means we rather have the left-hand side than the right-hand side. So there should be, when I change the input a little bit, there should be not a huge change in output. At least when I change the semantic of the input, there should not be a big change in the output. And yeah, this is what good embeddings do. And then I can use these embeddings in the space to identify objects and the closeness of objects to each other. For example, when I have the 2 cent here, I could ask, okay, what are the other coins that are similar to 2 cent? And then I may got 1 cent and 5 cent because they are closest. And that's the whole purpose of embeddings. So that's nice. For coins, I have parameters. I have properties of these coins that I can utilize in order to put them in the space. But for text, it's completely non-obvious. What should these properties of text be? Should this be the length of text, the representation, how many E's are in the text, or how can I do this with text? And so I want the same for text. I want, when I have a question, I want some also representation, not in 3-dimensional, but a little bit more dimensions. So this 512 or 768 or more. So I want some representation. And people have a long time tried to figure out, okay, what do I do? Do I count characters? Do I do anything? But with the progress of language models, figured out, okay, best thing is we have a language model and we pump the text through this model and let the model decide what the vectors are and let the model train what is a good vector representation for a certain text. And these are embedding models. There's nothing else than getting text in and then getting a vector out. So that's a big difference to large language models where you put text in and you get text out. So they have a different input-output than large language models. And a vector is intrinsically not as nice. So if you give me a text and I give you 20 vectors for this text back or 1 vector, you can do nothing with it immediately. But it's a nice tool to, because these vectors have this property of similar items are close to each other. So if I choose a Wikipedia article about elephants, then the vector about elephants will be close to the vector of my question. But when I choose a Wikipedia article about something different, like BMW, then the vector representation of this Wikipedia article will be quite different. And when I ask this question and I want to get the correct Wikipedia article to answer my question, I can use embedding models to figure out which is the correct Wikipedia article. So that's what I just said. Somehow that similar articles, they have close embeddings, and not so similar article, the embeddings are farther away. So what I can actually do with embeddings, I can do knowledge retrieval. I can retrieve, when I have a question or when I have some fact or some document, I can retrieve similar documents. And that's what we wanted to actually achieve. So we have questions and we have a lot of documents, and then I have an embedding model, and then I can use this to find similarity between an embedding and the relevant document. And then I need also vector DBs, so there are a lot of vector DBs around in order to store things and look things up, but in the end the embedding model gives you the smartness, the knowledge in order to make the matching. And then when you may have heard about RAG, or retrieval augmented generation. The left-hand side is exactly the retrieval part. I retrieve the relevant information, and the right-hand side is the generation part. I generate then the right output. And tomorrow morning there will be a talk by Michael de Rue from DataStax, and he will also talk more about RAG. So if that is something where you feel sounds interesting, go there and watch this talk. I'm pretty sure it will be great. So to summarize what we've had so far, large language models are really good in text processing and in text synthesis, and embedding models are good in knowledge retrieval. But in order to somehow spur your creativity a little bit, so what documents could I search for? That could be, for example, an internal company wiki. That could be a company PDF selection, for example, all the invoices, if you want to ask questions about invoices. That could be video or podcast transcripts. That could be all your private data on your local machine. That could be all case documents in a certain domain of law. So whatever you can think about. So a certain collection of documents where you know, okay, in this collection, when I ask a question, the answer will be somewhere in this pile, and I need to figure out the pile. And this whole question answering, embeddings are crucial, because these large language models, as I explained earlier, only work great with good context. And the quality of the final answer is pretty much dominated by the quality of the context that I give to the large language model. If I put garbage in, I get garbage out. So this is one specific use case of embedding models. You can do quite some other things with them. So one thing is general semantic search. So when you don't necessarily want a large language model behind them, you can just retrieve relevant documents. For example, in e-commerce, when you have a user query, you can use embeddings to find relevant products to sell. Or in general, when you just want to retrieve the documents, then embeddings are a good choice. You can also utilize them for clustering. So you can, when you have a lot of documents, you can embed them, and then you can similar vectors put them in one cluster. So they're also very useful there. Or in recommendation systems, you can use them. So there are quite some other use cases for embeddings. So I'm from GNAI, I said this earlier, and we also have trained embedding models, and you can find them under this link. The QR code should work. And we also open source them. So if you want to use them in your own environment, we open source them on Hugging Face. Feel free to go there and get them. And we also put them on AWS for now. So when you are on AWS with SageMaker, you can easily spin them up and use them if you want it in your own private environment, but don't want to hassle with any setup steps. That might be quite useful. And okay, why should you use our embedding models? So what is the specialty of our embedding models? So first of all, they have an 8K context length, so you can put in quite long documents. The second part is we designed them to be bilingual. It's always English plus a second language. Second language that we have so far is German, Spanish, Chinese, and code, because code is often a needed second part. And why do we choose the bilingual part? Is that bilingual model have, for technical reasons, perform often much better than models where you have a lot of different languages. Because when you add more different languages, models get some confused about tokens, about the texts, the meanings of text. If you choose less languages, they are more precise. So there were quite some experiments before, and also where you show, okay, multilingual models on English always perform way worse than English models on English. And so, we decided to not go too many languages at the same time for now. Then our models are quite fast, so small in the first case, and as a consequence, they're fast. They're open source. And the last statement might be a little bit provocative, but when we see benchmarks in the wild, where people benchmark different embedding models against each other, ours is usually in the top performance. So even though on the traditional benchmarks, it's not always at the top. In the wild, it's quite good. And we did not optimize it too much towards benchmarks that are there existing in the wild. Like the MTB leaderboard is a typical leaderboard where embedding models are benchmarked. And we did not optimize too much for this leaderboard, which consequences we're not so good at this leaderboard. But on the other hand, we're really good in the wild, which might be more relevant for you. And actually, we are really interested in your use case. And if you like this hoodie or the other swag we have, share your use case with us, and you have the chance to win the hoodie. So I will leave the slide on a little bit in case you are interested in getting nice swag. And the reason why we're interested here is that we believe embedding models have really strong capabilities, but we are also looking, I want to understand more use cases of them. So I want to understand more, okay, what do people believe, which specific problems they want to solve? Because we are training more generations of them, and we want to understand, okay, where should we optimize these generations for? Because during the training, you can always say, okay, I take a little bit more care about classification, for example, or I take a little bit more care about semantics in law or in other domains. And wherever we want to push our next models, it's always interesting for us, what do people need? And we will open source them, so you will benefit if you share your use case with us. And you may win. Awesome. That's it. I hope you don't mind if I'm 10 minutes earlier than usual, but it's the last talk, so I thought I'd make it short.